Welcome back to the Engineerable channel. In this video, I'm going to show how I made and added a leg protecting fender to the Razor DXT drift trike. This drift trike has been a hell of fun, but one thing I do not like is that when you're turning really hard, like in a drift, you need to bend your leg in some weird positions to avoid rubbing your pants or your leg itself on the wheel. And in winter, when I'm riding with long pants on, I don't want to tear them up by the wheel rubbing up against them. Or you have to like move your leg away like this, then put it back on when you straighten back out. So the same thing with the other side, like it's really easy to hit that wheel. And this problem is especially bad on a pedal drift trike because when you're pedaling, you're constantly changing the position of your legs and you need to kind of pedal to go around turns and stuff too. And it's really easy to drag your pants leg on the wheel like that, which is not great for your pants. So here I'm demonstrating a slow speed, but when you're turning, it's really easy to drag the pant leg on the wheel, and so unless you pull your leg away like that. So that's why I designed and 3D printed this fender that can easily clip onto the legs of the drift trike fork. Check this out, it actually printed. Wow, this is the biggest print I've ever done. I mean, it's massive on this pretty large IDEX printer. So the surface finish is definitely not perfect and could be improved. There's a lot of wobble that was happening in these thin walls. But in the future, I think I would provide some little reinforcement ribs behind these that would provide structure in this direction such that it wouldn't move back and forth. Because look at this, it's just really wiggly at the top here. There's just no structure for it, and I've probably messed things up just by moving it like that. And it's got better as it got higher up here, although I noticed that, let's take this off this build plate. It stuck pretty well to the build plate. As expected under here, it was pretty poorly supported, so it pulled away a little bit, but looks mostly good on the top side. There's just a little problem right here, a little bump that happened there. Not the most beautiful print ever, but I think it's going to serve its purpose well. So my original intention was to use zip ties to hold it onto the fork, but in order to take it on and off easily as I'm experimenting with it, I'm going to use some Velcro straps that I cut like this to length. So just attach these Velcro straps around the fork legs and through these holes that were meant for the zip ties. So this was my first attempt at 3D printing this fender. Watch as I design this fender in Onshape, my favorite 3D design CAD software. Now making this fender was a first in many aspects for me. It was the biggest 3D print I've ever made in one single part, in one shot. It's the first time I've used this NinjaFlex Cheetah TPU. I usually use the NinjaFlex regular, which is like an 80 to 85A durometer, which is softer than this material. So this NinjaFlex Cheetah is a 95A TPU, which is more rigid, feeds easier, prints easier, but it's still not rigid enough. And I wanted something that was flexible here so it would survive impact and it wouldn't break. You could beat it up, but it ends up being a little bit too flexible for this because my clearances are pretty close here and it ends up rubbing against the tire too easily. So I'm going to improve this design a little bit, add a little bit more clearance around the tire, and I'm going to 3D print this in a stiffer material and try to reduce the rubbing that happens. It clears, but as soon as your leg touches this, it starts to rub. So I hadn't done a lot of testing with this NinjaFlex Cheetah TPU before printing this. I just printed a small cube, made sure my settings were good for that, and started printing this. And there are some things that I would change about this because the layers at the bottom were really perfect, but I didn't use any support material. So as the layers went up here, it was just too flexible, this wall, when it was printing, and it would push it aside and did a lot of mess ups. Although, overall the print came out, the print didn't fail. I'm very happy about that. I noticed that these big layer lines here seem to coincide with when I opened up the enclosure that the 3D printer is in, and it's very cold in the shop right now and the enclosure was warm inside, and as I was observing it, it seemed to create those lines like there was a change in the temperature and something was changing with the position of the material. And so that's the thing, like don't open your 3D printer for too long to observe it while it's printing, because a change in temperature inside your 3D printer is going to cause some changes with the 3D print. Now the reason that I made these extended diamond-like hexagons instead of regular hexagons is I wanted this angle to be pretty steep such that it did not need any support material, and that worked out really well. So I'm definitely going to have to add some more clearance between the fender and the tire so that the tire doesn't rub so easily on the fender, especially as the forks are flexing. And as you apply pressure against the fender, I want the fender to be stiffer and have more clearance and not rub on the tire. Although, you know, this works, it does its job, it looks pretty cool. I'm not going to toss this. I'm going to keep using it until it gets worn out, if it gets worn out at all, because this rubber is pretty durable. So what's next? Well, I'm going to improve this design to add more clearance, make it more rigid, and attempt to print it out of a more rigid material. I'm probably actually going to try a PLA Plus material because this part is so big, I don't want anything that's going to shrink and warp, and the PLA Plus is pretty impact resistant. So it'd probably be a good material to do this with. If you want to make your own fender like this for your Razor drift trike, then check out the links in the description. I'm going to provide links to where you can download the files for this. I'm going to have several different versions. This version requires a large printer, something with a bed of at least about 280 by 280 millimeters. But I'm also going to provide a different version which is going to be made up of smaller pieces which you can print out and then glue them together to create a larger one like this. Boom! See you in the next video.